So we're going to start another wonderful topic called array. So what is an array? Let's start. What is an array? So previously, when you're using a single data variable, now assuming that I ask you to write a program that find the average bill, average phone bills for a year. So what are you going to do? So that means you're going to consider the bill from January, February, March, up to December. So what do? You will need 12 values, one for each month in the year, and you will ask the user to enter 12 values. Do you understand what I'm saying? So it means you're going to create 12 variables, a variable to store the value for January, another variable to store the value for February, March, up to December. You now add all the variables together and you display and find the average, divide by 12, and you display the result. So it means you're going to be declaring 12 variables plus another variable to store our average. So it means you're going to be having about 13 variables all together. So let's look at this program that calculates the average. So looking at this program, you will see, okay, I'm not going to start from the IOStream int main. You can see from here, we declared January, February, March, April, up to December. They are all what? Float. They're all declared as floats. And we declare an extra variable called AVE, that is to say average, to store the average value of these 12 months. You can see we declared January, February, March, all this to December, and we ask the user to input the value for January bill, February bill, March bill, up to December. We're not going to waste our time writing all that, up to December. So as the user is inputting the value, it will be stored in the variables, right? Okay, so as in this line, as the user input the value for January, that means the January variable will have a value, February will have a value, up to December. Then we can now do our computation. We can find the average in this way. So January plus February, March, blah, 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 up to December divided by 12.0 to give us a floating point value. So AV, we have what? The average value, right? So that's how you would do it before this topic called array. Okay, so what if you want to find the average for, let's say, 1,000 user? Are you going to start declaring, okay, user 1, user 2, user 3, user 4, user 5, up to user 1,000? That's cumbersome, right? So in this topic called array, the C++ allows the programmer to declare an array. That is to say, which groups together variable of same type. It groups together variables of what? Of same type. And it refers to this group of values using what? A single name. So we can say an array is a group of variables of the same data type, that are referenced using a single name. So once more, an array can be termed as a group of variables of same data type, and they are referenced with what? With a single name. Okay, so and each array member is accessed using what? An array index position. Just like in your family, you might have 5 kids, right? All of you are bearing the same surname, but we reference different, each of you using an index. You can say firstborn, secondborn, thirdborn, fourthborn, fifthborn. So the positioning though you are all using the same name, but the positioning allows you to be able to contact each member of or each element of the array. So an array index is what? Is an integer value. So you can either be the first, second, third, fourth. So you can't have I'm the first and the half in my family. There's nothing like that. I'm the first child, I'm the second child, I'm the third, I'm the fourth, fifth, and so on and so forth. So you can see array. You can group together variables of the same data type. All right. So what is the format for an array? How do you declare an array? You declare an array using what? A data type such as float, integer, double, char, bool, and so on and so forth. Now the array name, you have to give your array name a name, right? And the size. The size will tell you how many variables do you want to declare. So all what you're saying is this size, if I declare my size as 10, it means I'm creating what? 10 variables. 10 variables of the same data type. So assuming this is float, and let me say year as the array name. So it means I'm creating 10 what? 10 variables of the same array name, of the name year, and they're of the same data type. So just like this, just imagine you are going to be having 10, just like your cupboard or your shelf, your bookshelf, up to 10. 1, 2, up to 10. You understand? So it means you're creating variables of the same type, data type, that are referenced with the same name. So all of them bear the same name, yeah, and they are of the same data type, but they are of different position. They are of different position. So the data type is the fundamental data type. The array name is the variable name for the array, the one you give to the array. And the size is an integer that represents how many variables are in the array. So assuming that you want to write a program that average the phone bill for a year, starting from January and ending in what? December. So you can create an array of 12 floating point values. 12. You can now create an array of 12 floating point values declared as this. So what's the data type? The data type is float. The array name is what? Phone bills. And the size, how many variables are you declaring? 12. 12. So the size is often referred to as the dimension. What is the size? So when a programmer creates a list using a one-dimension size, as we did with the phone bill, it is referred to as what? Single dimensional array. So this is a single what? Dimensional array, right? And these values are stored what? Contiguously, one after the other. One after the other. So in the memory, all right? So you can see that rather than saying January, February, March, April, May, up, do you understand? Because you might think, okay, it's just 12. What if you are given to get the data of 10,000 people? Are you going to start counting? So it means with a single swing of command, you can create as much variable that you want. So just typing this, you can see you've created how many? 12 variables. But they are of the same data type and the same name, right? Okay, so let's move on. So this figure illustrates the phone bill or phone cost array. It is useful to visualize an array as a group of boxes. Yes, as a stack of boxes. Okay, where each box represents what? A separate variable location, and each box has its own name, right? So the array index is used to access what the individual what element. So it is the array index that you will use to access what the individual element. So using this command now, you've been able to create 12 phone bills. 12 phone bills. You can see they are all phone bills and they are of floating point data type. They are float. But how do you access each? So it means this first guy is phone bill 0. This other one is phone bill 1. You access each position using what? The index. The index. Look at the index. So the data type, the way you declare an array is you use what? A square bracket. A square bracket. Do you understand? If we have to declare a function, we use what? A parenthesis for a function. But for an array, you use what we call a square bracket. So you put the size in the middle, the number of array elements you want to create. But if with a full swing, you created 12 variables, how do you access each? Remember, all of them have the same array name, but how do you access individual boxes or individual cell? You use the position, right? So that's it. This accesses the first, the second. Now the last will be what? Last will be 11. So let's move on. So then you can see we can then put value. We can then put value inside each variable, each array location. So what we're doing is we are assigning 3.465 into what? Into this array position. That is to say, we are accessing the fifth guy, the fifth array variable. Okay. Likewise, this is how you can now assign value. This is an example of how you assign value to your array variable. Okay, so this shows the individual values in what? In the bill array, how they are assigned values. So let's look at more declaration. So what if I want to declare 1,000 integer? 1,000 integer. So using the array name count. So 1,000 integer, what's the format? The data type, the array name, right? And the size. What is the size in this case? 1,000. Okay. So what if I need 200 double variables, right? I'd use the data type. You can see is the declaration for an array is not far-fetched from the way we declare our variable. How do we declare our normal variable? The data type followed by what? The variable name, right? But now, since we are declaring more than one, so it means we are creating an array, you understand? So you have to put it in a square bracket and the size. So here, right now, with just this command, you've created 1,000 variables that are stored contiguously, one after the other. 1,000. So you don't need to start typing count 1, int count 1, comma count 2, count 3, count. Do you understand? That's cumbersome. Engineers or programmers always look for ways to simplify life. So yeah, we've been able to create 200 variables of the type what? Double. Here we have been able to create 25 character, you can see 25 array of what character. So let me just give you a quick dive. Now, you know our character always allows us to input just a single character. You understand? Using our data type. If you say char name, just ordinary char name, what you can input in there is just one character. It's just one character. Let's say U. You understand? U, V, A. But what if you need to spell University of Lagos? That's not just one character, that's string, collection of characters. So then you can use this array, right? So, okay. So you need to understand that in array in C++ are what? Zero index. Zero index means the starting element has the starting position of 0, not 1. Do you understand? Not 1. You know, if we have to count, normally we always say, okay, if I'm creating 1,000 variable, so first we say, okay, variable number 1, variable number 2, variable number 3. But in array, we always start with what? The 0 index. So C++ array are referred to as 0 index, which means that the array elements are numbered starting from what? From 0. Starting from 0. So now someone asked me, is string not a data type in C++? Now let me use the string. I won't say it is a data type per se. Let me. String is more like a class. String is a class. Don't let me say more like a class. String is a class. So a class, you can use a class to create variables. We'll get there, let's say in the next semester. String can be used to create variables, right? It is not only your fundamental data type that you can use to create variables. Do you understand? So you can use string. String is a class to create variables, but string is not a fundamental. It's not a fundamental data type. Do you understand? Is a let me say a class. A class is also seen as a data type. So if I create my own class will not be a fundamental data type. You understand? It's more like an advanced data type, user-defined data type. It's just like when you start defining your primary colors, red, yellow, blue, right? That's our fundamental colors. But when you start saying, okay, I want yellow, I want other variation of colors, those are advanced. Do you understand? Those are secondary colors, right? So to save us the stress of defining all this array, when you need string of character, the safest way is you just type string followed by the variable name. Do you understand? That will allow you to give multiple character. Do you understand? So I hope you understood what I just explained. So let me see. Okay. Toby Taiwo is asking me that I should come again how to declare multiple characters using char. Good. Let me go back. Let me go back. Now, you know, I told you that using your fundamental data type char, you understand? When you use it to declare a variable, you can only input a single. You can try it. Try to run your your code, you can only input a single value to it. What if you need a string of characters? Do you understand? You need to type your name. You need to type, let's say, University of Lagos. That is not one. That's no more a single character, right? So it means you will need what? You will need an array. So now I can now say, okay, I want to create a name that has 25 letters, right? But I don't want to dive in. I don't want to dive in too much, right? So this is how you declare. This is how you declare your array of characters. Okay. As we proceed, you will have more understanding. Okay. So like I told you that C++ array has 0 what? Index. So they're 0. The starting number is what? 0, not 1. Please don't make the mistake. Okay. So the name of the first element of any array as what? 0 as what? Is first index of first value. And the last element has a size of what? Size minus 1. So if you're creating an array of 12 variables, the first one will be what? 0. And the last one will be what? 11. Okay. All right. So someone is asking me, what's the difference between float and multiple character? I wonder why Tolulope is asking this question. Okay, but it's all good. Now, float, like I told you, float is a data type, fundamental data type, right? So you can't create a variable. Now, data type means you want to use it to create variables, and those variables will store a value. So what type of data is that value going to will that value be, or will that variable store, right? So when you say data type, what type of data is that variable going to store? Is it a whole number? Is it a real number? That is to say, number with decimal point, right? Is it an alphabet? Is it a Boolean value? So that would determine. So if you are going to store, let's say 40.5, 40.5, right? So it means the variable that we hold, let's say this, our CGPA, the variable name is CGPA. How do you declare this variable? You have to use floats, right? You use float. So you say float CGPA. Why? This is a real number. It has a decimal point. Assuming it's 40 now, you use what? Integer. You use integer. But what if it is a character, A, B, and C, A, B, and C, A, B, C, D, whatsoever? So this is character. So you use char to define your variable. Are we on the same page? So please, I thought we'll be more advanced. Well, it's good to ask questions now. Okay, so moving on, some programming languages such as Fortran formula translation allows the programmer to specify the starting array index, right? But C++ does not allow this choice. So some beginning C++ programmer who are used to writing Fortran code with a starting index of 1 will try to add an additional array element to the declaration and then ignore the first array element. This technique is not what recommended. What we're saying is, in previous or in some languages like Fortran, your array elements, index starts from 1. So if you are creating 12 variables, it means they start from 1, 2, 3, up to 12, right? So you just do the counting or the maths. So 1 to 12, that's 12. But if you are going to start with an array index of 0, your end value will be what? 11, because 0 is inclusive. 0 is a number. So what majority of them do is this Fortran programmer, or those that have experience about Fortran, start with 1, neglecting the variable with 0, right? So if we have boxes, in C++, it starts from 0, followed by 1, followed by 2, and the rest. You understand? So those programmers with Fortran experience sometimes start with this, neglecting what? Neglecting the 0 variable, right? And they tend to end with 12, which is out of the what? Out of the array elements. And this will what? We will make you to have some not error. You understand? Your system might crash. You understand? Depending on the compiler. Okay, so all array in C++ have the first index value. I need to mute. Someone is making a noise. Okay, let me mute everyone. Okay, so all array in C++ have the first index value of 0, and the last element is 1 less the sign. So please, as a note of warning, don't create your own indexing scheme. You follow the rules. Okay, so let's move on. So one-dimensional array initialization. One-dimensional array initialization. So what makes it one-dimensional? So it means you're declaring your array just more like a vector. You understand? Just in one dimension. You understand? Just in one dimension. So as you move on in programming, you might have what we call two-dimension. So two-dimension. So you'll be having rows and columns. Do you understand? There was a time I gave an is it an exam or test on metrics, 3x3 or 2x2 metrics. I might return the question 2x2. So it means just imagine your metrics as this. So you have a let me say A00, A11, right? A10, okay, sorry, is 01. So here will be what? A11. You understand? So you can see rows, just imagine just rows and column. You understand? So it's a two-dimension. It's two-dimension. You understand? If you have to create two-dimension, let's say matrix, you would just say for the row 2 by 2. These are you define two-dimension. But when it comes to one dimension, just your row, do you understand? So just a single column having multiple rows. Okay. All right. So C++ does not automatically initialize a declared array to any value. You need to note that. However, it is possible to initialize array of values. That is to say, assign values into the array element when they are declared. Just like I told you that when you're declaring a variable, you can declare and initialize at the same time. So you can say int A equals 12. What you're doing, 12, what you're doing is you're declaring this variable to be of type integer. That is to say, the value this variable A will be storing will be a whole number, right? Integer, whole number. So you're declaring and you are initialization, or you are initializing rather. So it's also possible that when you create an array, you initialize it. So the general format for initializing the values of a one-dimension array is this. Just the way you create your array, right? And you list some values and the list of array values. You can see that your list is in what? Curly braces. Curly braces, right? So when you list the values, let's say 0, 1, 20, whatsoever. So this will go to the first guy, the second guy, the third. So the third index. So let's see. Okay. All right. So the list of array values is a list of the initial values for the array element. Commas must separate the values. So it must be comma separated list. Comma separated list. So the first value in the list is placed in the first element. The second value is placed in the second element, etc. So let's look at this. We declare a variable called comp underscore ratio. And how many variables are we declaring? 4, right? So it means starting from 0 to 3. 1, 2, and 3. Can you see? So comp ratio 1, comp, so ratio 0. So what you're doing is comp ratio 0 is what? 3.21. That's what you're doing. So comp ratio 1 will be what? This. So this is zeros, position 1, 2, and 3. So what we're saying is that in a full swing, we are what? Declaring an array and also what? Initializing it. All right, let's move on. So if we have list of arrays and we need to access the locations of the array variables, how can we traverse? How can we move from one location to the other? So we're going to employ what we call the for loop, right? We've talked about the for loop before. We've talked about the for loop when we're doing our iteration, the for loop. We said with the for loop, you can allow the compiler to execute a statement a certain number of times. So for loop is used when you know the number of times you want to execute. And can someone remind me the format for declaring a for loop? Anyone? Can anyone help me with the format in declaring a for loop? Let me see if you. Anyone who is online? Let me. Okay, Charles, unmute yourself and speak.
So we declare the for loop and we also give the condition for.
Okay. So how do you declare it? So what should I type? What should I write? Charles.
Yes, sir.
So how do you write a for loop statement?
For.
For, okay.
Open bracket.
Do I use these brackets? Is this what I will use?
No.
They call it, okay, so this is wrong. Okay, I purposely asked. I purposely asked that. Okay. Okay, so you use a for statement, right?
Yes, sir.
Followed by your what? Parentheses, followed by what?
Then your condition.
Your condition. So what's the condition like?
Can be like maybe less than. Can be like what are we doing exactly? What are we
Okay,
making it?
let's say I want to iterate let's say 4 times. I want to iterate 4 times. So I just want to get the condition. Just a single step.
For less than 3, I think.
Thank you, Tobiloba.
Things equals
Okay. Tobiloba. All right. So you need to understand that you need to declare a starting criterion, right? If you've not declared a variable before. So in I, let's say you're starting from 0 or you're starting from 1. You understand? So let's say we're starting from 1, 0, you put your what? Your semicolon, right? Followed by the delimiter where are you going to stop? Let's say I'm going to stop at the 5th guy, before the 5th guy, that's at the 4th position, right? And how do you want to increment it?
plus 1.
Yeah, so plus. So, right, so what I'm doing is my starting criterion, where am I starting from? What number am I starting from? When am I ending, and how do I increment? You understand? So with this, you can loop through or traverse through an array, right? So the for loop provides an efficient method for going through each array variable, right? So the index of the loop not only is the counter for the loop. The index of the loop is not only the counter for the loop, but it can also be used as what? The index value for the array. For the index value for the array. So let's see. The form build program can be written with the for loop, and the index is used to access what? Each element what? Of the array. So let's see. Looking at our code, you can see here, what are we doing? We are setting up an array of what? 12 elements. How do we know it's 12? Yes, this is the size. How many array elements do you want? You understand? So they are of the type float. You understand? So we also create a variable called sum to help us undo the summation, and another variable to hold the average value, right? So if we have to obtain the monthly information from the user, we just use a for loop, because we are going to ask the user how many times? 12 times to input their phone bill for January, for March, for April, and the like. So we use what? We use a for loop to traverse. The for loop we ask, we say, okay, so please enter the bill for months. We are starting from 0. So it will be month one. Do you understand? The first month in dollar. Someone is raising. I know to Biloba, please. Can you ask your question?
Sir, why is the sum equals to 0?
Yes. Now, the sum is going to hold a value, right? The addition. So you set your sum to be what? 0. 0 means nothing, right? Because you need to use your sum here. So we'll get there. We'll get there. So this, I've already created my my counter before, So that's why you're not seeing int high. Do you understand? That's why you're not seeing int high. Okay, so I just I equals 0, I less than 12. Less than 12 means the max for I will be what? What will be the maximum number for I? Anyone?
11.
11, sir.
Yeah, wonderful, wonderful. So it means, but what if I want to include 12? How will I write this statement? How do I rewrite it?
Less than equal to.
God bless you. So I can say I is less or equal to. So it means 12 it will be inclusive. Wonderful, I'm impressed. So 12 will be inclusive. So it means I'm going to loop, the compiler will loop over this statement. How many times? 12 times. So it will say, okay, please enter the bill for, first month. We don't say month 0. Okay, so that's why we're adding 1. So it means 0. The I is also used as a counter. 0 plus 1, that's month 1, right? So the value, we ask the user to input the value. The value will be stored in what? Form B what? Form B what? Form B with the index of 0, right? Yes, because I is 0. Because as we created this array, it means just envisage we are having 12 boxes, right? 12 boxes. So the first box has the index of what? It has the index of 0, right? So it will be form view position number 0. So when I is 0, so we are inputting our value to what? To this location. So let's say this is 12.5. Let's say 12.5. So I get incremented, I becomes 1. It asks itself, is 1 less than 12? Yes, 1 is. So let me go again. For month 2, it goes to position number what? Form build. Do you understand? Form build 1 comes here. Form build 1. So it means with the for loop, as I is incremented, it means you're moving through the individual cells. Individual cells. So it means you've been able to store the value in each location. Now, how do we add? How do we add? So sum is already 0. So you understand, you still use the same for loop because you are going to be adding this first variable plus sum. You understand? One thing about this is just imagine you are having an account. As you're adding value to the account, your account is incremented, right? This is incremented. The sum is incremented. So previously, the sum is 0 plus the first value plus 12.5. Sum becomes 12.5. Do you understand? For form view, let's say this is 10. It will become plus 10. 12.5 plus 10 plus this plus that. So you can use your for loop to what? To traverse. You use your for loop to traverse. I think any question? Hope we understood. Any question?
So why do we have, or what does the dollar sign you have there mean?
No. The dollar sign has nothing. It's just, since we cannot write naira, do you understand? So the dollar sign is just to say, okay, please input the bill for months, for month 1 in dollars. Do you understand? So it doesn't mean anything. You can see these are string, right? These are string. Okay, so any other person? Hope we're good. So the sum is just to add. Now I want to ask, can we simplify this expression? Can we simplify this expression in a better way? I taught you guys prior to you leaving campus how you can simplify this. Anyone? Anyone? God bless you. Who is this Bello? Bello Emmanuel. I'm impressed. Bello, I'm impressed. Emmanuel, I'm impressed. Yes. So what you do is you just say sum plus equals form view. The programming is excellent. Form, please, I don't want to write everything. I just say form view views I. Form views I. Wonderful. This means sum equals sum plus. Someone is asking me, is there no other way of doing it without assigning 0, doing for the sum? Well, you won't you don't want to, this convention is the normal convention. Is a normal convention. Just think about it. Is a normal convention. Else, except if you want to say form bill I plus form bill, do you understand? That might look cumbersome. Form bill 1, you can't be doing this. If you want to use this, you can't be doing form bill 1 plus form bill 2. That will work, but to save you, just declare this sum as 0. So as you add this to it, your sum is incremented from every is incremented. So here, the last statement, what are you doing here? You're finding the average, right? After adding everything, you're now finding the average. So you can now display your average form views to the screen. I don't think that's hard. That's simple. That's simple enough. That's simple enough. That's simple enough. All right. You can come out with another algorithm or formula to do that, but that's so what now, looking at the array, the first for loop, you can see the first for loop when we're asking the user input or enter the view for month number, we start with 0. So month 1, there's nothing like month 0. So the first time this loop runs, I is 0, it asks the user for month 1, that is to say I plus 1, which is 0 plus 1. So assuming the user places 14 points, input for 145.23, so it means in the form view position 0, this is what it would be. The second time this loop runs, I becomes 1. So it asks the user once for month number 2, assuming the user enters this will be placed there, and the rest. You understand? So that's how you move. That's how you move using your for loop. The first month, second month, third month. That's how you move. Using what? Using your for loop. Using your for loop. So someone said, can we add the sum line of code to the first for loop? Yeah. You can do that. You can, yes, you can. You can do that. So what you do, I like the way you're reasoning. I like the way you're reasoning. So what you're just doing is we just say sum equals plus equals phone bill. So you remember, but this is where you have to get it right. The variable must there must be a value in the phone bill before you can add. You understand? So as you're asking the user, please enter the value for phone bill position 0, and the user input it. Then you can now add it immediately in the same way to the sum. So as the user is inputting the value, you're adding it to sum. You're adding it to sum. That's wonderful. But I intend using this so that it will be clear enough. You know, nice thinking. And let me tell you this: in real life, to solve a problem, you always have more than one solution. Just if I ask you to come to campus, you can come here using different routes. You can take different routes from wherever you are, different routes. So what I'm saying is, as you move on in programming, you start looking at what we call, you take a topic like algorithm and data structure. So it's not about you writing a working code. You need to start evaluating your code with respect to what? Speed and accuracy. You understand? Speed and accuracy. So if you have a code that executes within 2 seconds, and you have another code that still work the same execution, but it's taking, let's say, 1 minute, which one do you go for? Will you rather wait at the ATM machine for 2 seconds, or the ATM machine dispense after a minute? Do you understand? So as you start writing code, to begin to evaluate your code, right? So topics like algorithm and data structure start talking about the big old notation, the complexity, time curve of your code. Right. Nice thinking. Wonderful, wonderful. I'm impressed with this. Please, programming is lovely. Just ability to think, to use logic. Right. Good. Ayo, God bless you. All right. So let's move on. So the second for loop, now we are what? We're adding our what? Our phone bills. So when the first time this loop runs, I equals 0. So we're adding the first phone bill to what? To sum. We are updating the value of sum. As we add it, we update it. So we add it to the previous value of sum and we update. So sum becomes a newer value, right? The second time, I becomes 1. So it means you're accessing this second variable. You update it with the previous value of sum. You get that? So that's how you traverse, how you move from each location using what? The for loop. You need to ask yourself, how many variable am I going to access? So that will give you a notion about your index. So the loop executes 12 times, and each time it accesses different elements. It's just like this. I want to give you money. So first you say, okay, the first born, the second born, you understand, because the I is increasing. The third born, the fourth born, or the first guy in the row, the second guy in the row, the third guy in the row, and go on. So the for loop index is a convenient tool to use. So also looking at this, you can set up an array element of, you understand, of 4 elements, array of 4 elements. Okay, you can input the value individually as long as the compiler understands this. It means you are accessing the 0th, the first element. Do you understand? When I say the 0th, you know what I'm saying. So likewise, and you can then add. You can see, still the same, right? I hope I'm communicating. Is anyone confused? Any question? Okay. So I want you to note that for every array there is invariably or implicitly a pointer is always created. A pointer is always created for every array element. A pointer, no, when an array is created, a pointer is invariably created. So I want you to look at this code. You understand this code, okay? So just look at this. Assuming you just you want to display what is in comp ratio. You want to display what is in the comp ratio, and you mistakenly, instead of putting the index, right, you just write out this array name, right? So you will see it will compile without an error, and it will give you this output. If you can see this, what do you think this looks like? 0066 FDD8. What does it look like?
The address.
It looks like an address. God bless you. So this, on the computer memory location, or the memory address of this, you can see is in hexadecimal format. You understand? So what this means is the address of the 0th guy, the address of what? Of the 0th guy. So every time you create an array, a pointer is implicitly, is not clearly stated, but is implicitly stated. It's just like when you give birth to a child, implicitly there's a position attached to the child. Is either the first, the second, or the third. So I will explain why it's the first, is the first variable that the pointer maps to. Okay. Okay. So with the declaration of any array in C++, the language automatically generates an array pointer, which is a pointer of the same data type and the same name, right? So the pointer will be assigned the address of the 0th element. of the array. So when you create this array, your program automatically gets this. This is what will be done implicitly. At the back end, your program will have this. So this pointer is available and can be used whenever a pointer to an array is needed. So when you need pointer to an array, you don't need to create this again. It's implicitly stated. That is to say, there's a pointer created with this, which maps to what? Which maps to the 0th element. Okay. So if you create an array, as in this case, a pointer is automatically what? Declared. And the pointer maps to what? The address of what? You can see address is, this pointer is pointing to the address of what? The 0th element. So the pointer, the phone bill points where? It points there. Why? Why? Because with the first element, you can reference any other ones. With this first element, you can reference any other one, right? So this second guy is just phone bill plus 1. You understand? Plus 1. Phone bill. Now from here you can access the second guy. It's what? Plus 2, plus 3, and the likes. You understand? So this array pointer, this pointer is available and can be used whenever a pointer to an array is needed. So examination of the portion of the compression ratio program, it should be noted that the array is initially declared with this statement. So you can see that when also in this example, as you create this array, when you use the name, it will give you the address of what? Of the 0 index. Okay. So you can assign value. You can assign value to each of the elements. And actually, the first element address was not assigned to any pointer, but well, C++ assign it automatically. You can see we did not create any pointer. We did not say, oh, let's say floats. You did not see us doing this. Float asterisk, comp, whatever. There's no way I typed it, but automatically, if you run this code, and try to say cout comp, I will try to I'll see how I can simulate that. Hello class, I want to ask you, do you have any lecture after this class? Anyone? So that even if it will take me extra minutes, I just want to show you practical wise. Anyone? Let me see. Yes, sir, by 11. Wow, 11. Okay. 11. So I have about 13 minutes more, 12 minutes more. Okay, so let's move on. Okay, so what we're saying is when you just write the array name, the pointer points you to what? The compiler points you to what? The address of the first guy. So the output shows the hexadecimal address contained in what? In the pointer, which is actually the memory address for the what? For the 0th, sometimes when we are describing a place, we always reference it. We'll say, okay, when you get to this house, to this yellow house, the house painted yellow, just look about 3 blocks away. Do you understand? So the house painted yellow becomes a reference. So 2-3 blocks away, is what we call the displacement. You understand? So if you can reference the 0th guy, so you can get the 1st, 2nd, 3rd, 4th, and the rest. Okay, let's see. So what are we saying? When an array is declared in C++, the language automatically provides a pointer to the same type and name, and it points to what? The first guy. So what I will do is I will drop an assignment on LMS, and also on Facebook, on YouTube. Expect a video on a practical video. I would like to show you some things and do a recap of what we've studied. So next week will be our test. It will be definitely communicated to you on LMS. LMS is back, so check LMS next week. That's the same time next week. That's August 27. Okay, so now please, you need to pay attention to this. Passing one-dimension arrays to functions. Passing one-dimension array. The name of the array is used in the call statement when an array is passed to a function. Yes. So using the name of the array without any array bracket actually passes what? The address of the array to the function. So in the function statement, let's say we are calling an array now. Let's say the name of the function is get array value. Let's say this is the name of the function, and the array is empty, get array value. The array is empty. I want to pass in value to the array. So just mere imputing the array name, that's what it's saying. When the array is passed into the call statement, let me mute. Someone is making a noise. Let me mute all. So when we pass the array name to it, let's say comp ratio, let me say comp ratio. What we're actually doing, is we are passing an address at this comp ratio. We are passing the address of the 0th guy to what? To this function. We are passing what? The address of this. Remember, whenever you just display the array name, what you're going to be saying is what? An hexadecimal address. True. So invariably, you would think this is a call by value because you are just passing a variable name, You think it's a call by value, but actually it is what? Call by what? Reference. We are passing an address. We are passing an address. So that's what I want you to note. What address are we passing? The address of what? The 0th element. That's the address we are passing. So using the name of the array without any square bracket actually passes what? The address of the array to the function. So when the calling function uses the array, it is using the calling function's what? Array data. So as you're passing the address to that function, any value you input in the function header line and body of this, you are actually sending the value directly to the what? To the call function array. So therefore, sending an array to a function appears to be sending a copy of the array, that is to say call by value. But in actuality, it is sending what? An address. You know, previously I said, okay, if you send a variable to a function, you know, it's called by value because there will be a value in that variable. So you're passing a copy of that variable to that function. Yes. So this looks like the array name, right? It looks like the array variable name. But in actuality, when it comes to array, you're not just passing, you're passing an address. That's what I want you to know. Okay. So the manner in which C++ handles array is what? Memory efficient. Because array can be big. Array can be what? Can be big. Just imagine having the data of everyone in Nigeria. You can just think, oh, I'm just passing. It can be a lot of data. So rather than doing call by value, passing call by value, sending bulk data, what the way array does its thing is, or the way C++ handle array is, it sends the address. It doesn't want you to be moving the array data everywhere or duplicating it. So it will be sending the address of what? Of the array variable. So the program has only what? One copy of the array. The function do not create its own local copy. It does not. It does not. So this feature of the language is valuable because array may be quite large. Yes, your array may be quite large. Just imagine you're dealing with thousands of students. So creating individual copies of them in function will be what? Time consuming and waste of what? System memory. I hope you understand. Any question? Any question? Any question? Okay. Okay. Toby Lover. Toby. Toby Taiwo. Can you please ask your question? Toby. Toby. I can't hear you. You can drop your question in the chat box. So, okay. So, a function that uses an array must indicate the array data type in the prototype and function header line. So, using the array, the set of array operator bracket is how the program identifies the what? The data type as an array. So the next slide will illustrate two programs, one by passing a single float variable to a function and one by passing floating point array. So I just want you to notice what? The square bracket. When you see the square bracket, you know that we are talking about what? Array. Okay, let me. No. The address of the first element in the array is not the same as the address of other elements. You remember what I told you about array is that array, the variables of array are stored in contiguous location, one after the other. They are stored one after the other. So if the first one is the address is 0, 1, depending on the data type, let's say the data type is float. So 0, 1, you add 4 to it because float is 4 bytes. So add 4 bytes to it. So the next one will be starting with 0, 5. So array, whenever you are creating variables, just ordinary variables, they are not contiguous. But for array, the elements are contiguous. So with the zeroth guy, you can get the displacement. You can get the address for other array variable. So it's just a displacement. You understand? It's just more like when you build an estate. You know, you can move from the first building to the other, unlike just having houses scattered everywhere. So it's not the same. If we are passing an array into a function as argument, what data type do we specify? Is the data type of the array? Yeah. Okay, so let's look at an example, and all right. So looking at this, this is a single float value function, just a single value. We want to do the comparison with what a one-dimensional array, right? So how do we do our function before? We have a function prototype. This is a function prototype. Your function prototype is just telling the compiler, okay, this is my function name, and this the return type, and this is my data type. So with the function, with the function prototype, you can know how many input arguments the function we have. So this function has just one input argument of the type float. R0 is not returning anything. The function is not returning anything, right? So and look at it here. We created a local variable x. We pass it to this function. So you can see that this function header line, this float x is a variable that belongs to this function. Whatever you pass to this function will be received by what? By this variable. So if this variable, let's say float x, has the value of 5, so it means you're passing 5 to this function. This function now has what? As x. So it's more like float x equals what? 5, because it's going to be received. So float x equals 5. So this function has what? Its own local copy of what? Of this x. Do you understand? So here, what we do is call by what? Call by value. This is called by value. Someone asks, how do we see all the elements in the array? You print it out. Yes. You print it out. Yes. See out using for loop. Using for loop, you use your for loop and you say for see out using your array index. Can you please clarify which is the called and the calling function, Abba Israel? Now, this is the main function, right? In this example, this is the main function, and this is another function. Execution starts from this main function. Execution, program starts running from the main function. So this main function now, you can see is calling another function. So when this main function calls this another function, it's more like this function comes alive, it executes and returns. You understand? So this main function is what? The calling is the one calling another function. While this function one is what? Is the called. Is the called. This is the calling. The main function is the calling function. Do you understand? So me passing this variable name to this function, we are passing the value, right? So a copy of this variable value, the value stored in x is passed here. You understand? So, but when it comes to function, with this, our prototype, we can see that what we're going to be dealing with is what? An array. Look at this. This prompts the compiler that, see, watch out, this is an array, right? So you don't specify the size in the prototype, it's not needed. Okay, so coming to this main function, we created how many? An array of 100 what elements. So 100, starting from 0 to 99. 100 elements up to 99. You understand? So you can see, what do? We just pass the array name to the function. You understand? This looks like call by value, but it is not called by value. What you're doing invariably is you're passing an address. You're passing an address. The address you're passing is the address of the first guy, or you're passing the address of the first guy, which will be received by this. You understand? So this does not have a local copy of this. So anything you do here, the value is saved directly to this pointer. So please watch out for my YouTube tutorial. I would explain this better. Please watch out and subscribe. Subscribe to this channel so that you receive notification. Okay, so sir, can you please go over call by value, call by reference, please? Go back to the YouTube video. Go back to the YouTube video. Okay. Basically, call by value is you're passing the variable, you understand, to a function. As you're passing the variable to the function, you're passing the content, the value of that variable. A copy of this variable is passed to the function, right? A copy of this variable value is passed. So if this variable is having 5, you're passing 5 to this function. So it will be received by this, right? For call by reference means you're not going to be passing you'll be passing an address. So rather than writing this, you'll be passing what? Address of X. So if you pass it here, what will be receiving it will not just be an ordinary variable. What always receive address is a pointer. So here you'll be declaring something like float X underscore pointer. Let me erase. So here, if you're dealing with reference, you'll be passing the address of X, which will be received by what? A pointer. So this is the asterisk or indirection operator. So it will be received by X. So with X down, you can now send value. You can do send X. You understand? Send. So what you'll be doing is the value that will be given will be stored to where the pointer is pointing to. Where is the pointer pointing to? So the value you input here will be stored there. So this. So let me see. How many slides do I have? Please. This is already 11. I learned you're having a class right away. Please just watch for the YouTube channel. I will drop a comment or a video.
Sir.
Yes.
Can we also get this slide uploaded? Maybe immediately, sir. The LMS is back on, so we can actually if you can help us.
Definitely, I'll do that right away after this class.
Right. Thank you, sir.
And also send the link on YouTube.
All right, sir. Thank you.
So what I will do is, while you exit, I will continue to explain so that the whole video will be will be on YouTube. All right. So if you're having any class, just hello, Fetuga.
Yeah, please. How would the test be multiple? Will
Will
the
be
test be
what?
multiple choice questions?
Why will it be
Will the
multiple
test
choice? Why will it be multiple choice question? You are programming. So if a user comes to you and asks you, or a client asks you, create this program, will it be by theory? Is by coding? You need to understand that. So stop asking if it will be multiple choice. Okay. Anyways, for some of you that will not be online, I'll continue with my lecture slide. Okay, so the source code in the right column of the table contain an array of 100 value. You can see an array. The call statement to the function contains the name of the array, right? So this is actually passing. Please, you need to know that this is actually passing the address, which contains the address of what? The first element. So in function 2, the declaration of this, the float q with the square bracket, is declaring a local variable for the function, and the function uses normal array syntax to access it. So however, q in this function 2 is really a pointer to what? To the main. So this is what? Is a pointer to what? To this. Okay. So function 2 is using the calling functions data directly. Okay, so look at this. We said when you create an array, invariably you are having a pointer created for you automatically. You won't see it, but invariably at the back of the scene, you have that done for you. So when you're passing a variable name, you're actually passing this address. Passing the address. So the address, so if we assume that the address is this, you understand? The address of Q0 is passed to what? This function. Function 2 is accessing what? This array. So this is accessing. Anything you do here is actually affecting. So there's no local copy of what? There's no local copy of the array in the what? In this function 2. There's no local copy. There's only one pointer to what? To the main queue. All right. So a common requirement when working with a numeric array is calculating the average value of the array, a perfect situation for function. So the average value of a one-dimension array program uses a function called average one dimension, which returns the average value of the floating point array. So we need to pass the array and the number of the values in the array to the function. Okay. So look at this. So we have this. Prototype. We have this prototype. So this prototype have what? The array and what? The number of values. The number of values. That is to say the number of elements in that what? In that array. So look at this. We've been able to create an array of what? Of 100 variables that are referenced by what? X. So 100 floating point variables. So we also have an average of the type float, number of the type what? Float. So we created all these variables also. So now we want to fill in X with the value of 1000 to what? 1100. Understand? So what do we do? Because we want to fill in the value of X, what's the range of X? X is what? 100. So we start from 0 to what? 99. So we assign the value of number, that's 1000, to the 0th guy. We increment it. This become 1001. The next time, the X with 1, with index 1, we have 1001. X with index 2, 1002. So this is incrementing, and we are passing it back. So we call this function average. You can see we pass in the array and the total. So the total is the number of what? The number of index, or the number of elements in the array. So we display the average. Okay. So here now, this temp is local, right? So this temp is receiving what? What is the temp receiving? The temp is receiving the address of what? Of this array. So it means this temp is a pointer pointing to what? The array. Okay, and this total is 100. Okay, so we can now add. We can now add what? The temp to this to the sum. So we can add each individual element of what? What we're doing here is we are adding each element of what? Of X. You understand? So when we're through with what? We find the average. One thing I want you to note is this. Since we passed the address of X to this pointer, so this temp is accessing X. The X array is accessing the X array. You understand? So it can manipulate anything you do with this temp. You understand? It can fetch value. So you wonder, where do we get the value from temp? The value from temp is gotten from here. So this is just more or less in xi, because they're having the same address, xi. So you find the average and you return. Okay. So just look at this example. Look at this example. So we created 100 average. This we store the average. So the total is this. Okay, so we want to fill in the array with 8000 to 1099. So we pass X, the array, we pass the array, right? And what? We pass the total. So this total is 100. So like I told you that this, as you pass the array name, you're passing what? The address of the first element. You're passing into this function. So temp hold what? The address of what? Of the first element. You understand? So you can then add it. You can then add it and find the average. Okay. So in this example, the average one-dimension function appears to have its own local copy. Appears, no, which is incorrect. It's using the function as a pointer only to the calling function array. So it's using the calling function array. So if the function changes the array value, it is the calling function value that have to be what? Changed. So that's the end. That's the end of what? Of our topic. So I don't think we would have ample time to continue. Maybe you continue other topic in the next semester. All right.
So,
Hello.
so the test, will it be based on what you've taught us so far?
Definitely. Definitely.
Okay. So,
Yeah. It will be based on what you've been taught so far. So go and learn your function and pointers very well. That's basically what I would say. All right. I wish you all the best. It's good to have you. Thanks for joining today's class. So check on elements, you'll get updates. All right, bye. All right. Moyoluwa, God bless you. Good to have you. So I'll stop the recording. Are you asking a question?
Yes.
Okay, what's the question?
The test will be online, right?
It won't be online, it will be offline. We'll tell
And
you,
we
you
will
will use your system. Hopefully you use your system, you code and you upload. We'll give you the directive on what to do.
Okay.
So you code, you zip and upload.
Okay, sir.
All right, bye.
Okay, sir.